So let's take a look at this problem. How is it different than the problems we were doing yesterday? What do you see? Yeah, there's more than one radical, isn't it? We've got two radicals. I also have a term that's not under a radical. So yesterday for the radical problems, I told you that the first step was what? Isolate the radical. So we are going to get rid of one of these at a time. So I have to isolate one of them. So let's say I just pick the first one. I'm going to get it by itself. How would I move this radical to the other side? Add it over. Okay. Alright, so now, if I want to get rid of this radical, what's the opposite of a square root? Square. But when you square, you have to square each side. So on this side, the square root and the square would drop. What do you have to do over here? Foil it. So I have to actually write this twice and foil. Okay. So when I foil, 2 times 2 will give me a 4. Can you take that 2 under the radical? No, so that's just going to remain 2 radical x plus 2. Inside, so plus another 2 radical x plus 2. Last, when you take radical x plus 2 times radical x plus 2, what happens? It drops the radical. It's like having the square root of x plus 2 squared. So the square root goes away and just leaves me with a plain x plus 2. Okay, I know that got really messy in a hurry. What questions do you have right now? Yes?
Why can't you just square the 2 and square the x plus 2?
You can, because what we're doing, whatever you do to one side of the equation, you do to the other. So we're not going to individual terms and squaring. You have to do to the entire side. And so to square 2 terms at once, that's a binomial, so you FOIL. Other questions? Okay. So this looks pretty gross, but it's going to clean up fairly nice. So first thing, if I combine my like terms, I could subtract over my x. So that would just give me an x here. 4 plus 2 give me a 6. 2 radical x plus 2 and 2 radical x plus 2 would be 4 radical x plus 2. We have a radical problem still. What's that?
How'd you get this? Yeah, like, oh, so you just added 2 plus radical?
Yeah.
Oh, right, okay, never mind.
Alright, so it's a problem with the radical. How do we solve a problem with the radical? Isolate the radical. So I'm going to subtract my 6 over. You have the option, you can divide this 4, it will give us a fraction, or we can leave it, if you're okay with that. I think there's probably going to be less confusion if we just leave it for now, but we're going to square again. So I square each side. So this means x minus 3 times x minus 3. So if you FOIL, you get x squared minus 3x minus 3x, so minus 6x plus 9. On this side, when you square, you have to square the 4. 4 squared is 16. When you square the square root, it drops. So it's like 16 times x plus 2. So that gives me a 16x plus 32. Now I have a quadratic. How do you solve a quadratic? Set it equal to 0. So subtract over the 16x, subtract over the 32. Box method. What multiplies to negative 23 and adds to negative 22? Okay, set each of those to 0, and I get x to be 23 and negative 1. This is not a problem to skip steps on. If you write everything out, you'll be okay, but if you start trying to do things in your head with all the radicals and the squaring multiple times, you're going to get confused. What do we need to do at the end? Check. See if these things even work. So if I put a 23 in here and get 46, so the square root of 49 minus the square root of 25. So square root of 49 is 7 minus 5. Does that one work? Yeah. If I put in, what was my other one? Negative 1. So if I put it in that, I get negative 2 plus 3, so that's 1. Negative 1 plus 2 is 1. Radical 1 minus radical 1. That gives me 0. So does that work? No. So negative 1 does not work, and 23 is our only answer. The nice thing about these guys, if you're checking, you'll know if you got it or not. I'm guessing we'd probably like to see another one of those. What do we do first? Isolate the radical. So it doesn't matter which one you go with. I'm just going to isolate this one. So this will give me 2 plus the square root of x minus 1. Now we're going to get rid of a radical. So we square each side of the equation. On the left, the square and the square root drop. On the right, you have to think about writing that thing twice and quick. So 2 times 2 is 4. Plus 2 radical x minus 1. Plus 2 radical x minus 1. Am I going to lose you guys if I go ahead and combine those? Plus the last radical x minus 1 times radical x minus 1. It's just x minus 1. Everybody get to that step? All right, so we're going to isolate our radical again. So if I subtract my x over 4 and negative 1 will give me a 3. Subtract over my 3. squared. So over here, you have to realize I have this twice. So we get 4x squared minus 4x, so minus 8x plus 4. On this side, 4 squared is 16. Radical x minus 1 squared is x minus 1. So we get 16x minus 16. Okay, set this equal to 0. So if I subtract my 16x and add my 16, did you notice anything about that? We can factor out a 4. So we can either pull it out or just divide everything by 4. That'll give us a nicer problem. So I'm just going to divide both sides by 4. That would leave me with x squared minus 6x plus 5. What multiplies to 5 and adds to negative 6? Negative 5, negative 1. Set those to 0 and we get x to be 1 and 5. Am I done? Check it. So if you plug in a 1, you get square root of 4 minus the square root of 0, so that works. If you plug in a 5, you get the square root of 16 minus the square root of 4, so that would be 4 minus 2, which is 2. So in this case, they actually both work. Let's talk about the last type of problem. The last thing we're going to be looking at are quadratic type equations. So essentially what this is, it looks like a quadratic. It has a coefficient times something squared plus coefficient times something to the first plus a constant equals 0. But it's not always what you're used to seeing. You know, we're used to seeing quadratics like this. But I may see something like 3x to the 2/3 minus 2x to the 1/3. This is still like a quadratic. I have a constant. I have x to the 1/3. If you square x to the 1/3, you get x to the 2/3. So this first variable is the square of the second one. That makes it like a quadratic. It may be something like 3 times a minus b to the 4th minus 2 times a minus b plus 4. Okay, if I look at my variable part, a minus b squared. If I square that, I get a minus b to the 4th. That's what makes those like a quadratic. Okay, so what we are going to do on these problems is substitution. We'll take the ugly part out, we'll put a u in so it looks like a typical quadratic, factor it with that, and then replace at the end. Now I'm showing you substitution. Some people don't need that. Some people could just take this and do box method and they don't mind if the variables are different. It kind of depends on you. Okay, I'll show substitution. If you want me to show you another way, I can, but you just have to find something that makes sense to you. So let's take this particular problem. If I didn't show you any other method, if I just gave you this and told you to solve it, what could you do? You probably know at least one method that would work right now. Okay. You would have to first multiply everything out. You'd have to take your x plus 2 and square it, distribute your 11s, combine like terms, and then get a new quadratic that you could either factor with box method or quadratic formula. And if that makes sense to you and you want to do it, that's fine. What I am going to suggest is substitution. So I'm going to say let u equal. U is going to take the place of your x term, which is always that like middle term. So I'm going to say let my u be x plus 2. So then, if I'm looking at this, x plus 2 is going to get replaced with a u, and this was squared. Plus 11, x plus 2 we are changing to a u. Minus 12 equals 0. Alright, so then what do we do? We just took the problem and rewrote it so it looked a little cleaner. So u squared we break into u. Multiplies negative 12 and adds to positive 11. Negative 1, positive 12. Okay, we are solving this. So set each one to 0, so we get u to be 1 and negative 12. Everybody okay to that point? Okay, but my original problem didn't have u's in it. It had x's. So now we have to undo our substitution. What is u equal to? X plus 2. So that means x plus 2 equals 1. Or x plus 2 equals negative 12. Factor 2 and you get x to be at negative 1. So we use the substitution to give us an easier problem for factoring purposes. But at the end we have to undo our substitution, go back to our original variables. You can always check these just like the others. They should work as long as you've done it correctly. It's the radical problems where you get answers that don't always work. These, as long as our math is correct, should check out. I've got quite a few examples of this type. I'll do as many or as few as you guys need. So let's do at least 1 or 2 more, and then you guys let me know if you need more from there. Okay? Alright. Now this one. There's a couple ways to solve this. Without using substitution, how could you solve it? Subtract over the x, add over the 3, and it's a radical problem, isn't it? So you could solve it like the radicals, and that's fine. The other option, if you look at our variable part, the square root of x. If you square the square root of x, what do you get? X. So if I square that term, I get this one. So it's really like a quadratic also. Okay, so 2 different approaches. You'll get the same answer either way. You're welcome to do either approach. I'm going to try this one with substitution just to show you. Okay, so let x, or not x, u equal the square root of x. Okay, quick check to see if your substitution is going to work. You could just square each side. So u squared is the square root of x squared, which is just x. And that gave us our other term, like we said. So x is going to get changed to u squared plus 2 radical x becomes u minus 3 equals 0. What do I do from there? Multiply the negative 3, add the positive 2. Okay, set each one to 0, so I get u to be negative 3, and u to be positive 1. So, am I done? No. U is the square root of x, so that means the square root of x is negative 3. The square root of x is 1. Now this problem has radicals in it. Anytime you have radicals, you need to be aware that you might get answers that don't work. Do you see any problems right now? Okay. Yeah, a square root always gives you a positive answer, doesn't it? If I say the square root of 9, the answer is 3. Square root of 25 is 5. Can a square root equal a negative? No. You can catch it right now. If you didn't, and you just went through and squared each side, you get x equals 9. And when you plug 9 back in to check the original, it wouldn't work. So if you don't catch it now, just make sure you're thinking, okay, there was a radical in the problem, I need to check at the end. So that one doesn't work. Here, if we square, I get x equals 1. Should go ahead and check that, so that would be 1 plus 2 times the square root of 1 minus 3. So 1 plus 2 minus 3 does equal 0. This is one where substitution is probably going to be the easiest way to solve this problem. If I look, I always try to see if it works to make my u be just that many times. So let's say u is y to the 2/3. If you want to check to see if it works, try squaring each one. If you take y to the 2/3 and square it, what do you get? Y to the 4/3. Is that the other piece that I had? Yeah. So now what does my problem become? Y to the 4/3 is getting replaced with u squared minus 5. Y to the 2/3 is getting changed to u. Let's say equals 0. Multiply 6, add to negative 5. To get a positive, they have the same sign. So we would have negative 3, negative 2. Right? Set each one to 0. So I get u to be 2 and 3. But u was y to the 2/3. Okay. don't really struggle with what to do when you have a y to the 2/3, you can write that in radical form if that's easier. The denominator is what goes outside the radical, so this means like the cube root of y squared. How do you get rid of a cube root? Cube each side. So y squared equals 2 to the 3rd is 8. How do you get rid of a square? Square root, and if you have a square root, you also have to add. Can you break down the square root of 8? Yeah, square root of 4 would be 2. Get rid of the cube root, the cube. So I get y squared equals 27. Get rid of a square, we square a root. Plus or minus. 27 you could break into 9 and 3, so we get 3 right. So we got some uglier answers there. You can, but they should work on this problem. What I'm going to do, we have, alright, so we've still got about 20 minutes. I'm going to add 8 problems to last night's one. So a few of them have the multiple radicals, a few of them are like the quadratics. And then I just want to be here to answer questions over anything you're having trouble with. So I'll just be coming around. Make sure if you do get stuck on something, you ask me. Again, I pick all odd problems because I want you to be able to check these as you go and know if you're getting the right answers or not. EOO, you guys remember what that means? Every other odd. So if you don't like EOO, you could write them out.